Hello everyone and welcome to this tutorial. This is Hussein and today we'll be talking about the Newton-Raphson method. So if we have a random function, something that looks like this, and we ask it to find the roots for it. This function is something that we call the third order polynomial. It's because it intersects the x-axis 3 times. This is where the y values are equal to 0. And now we need to find those 3 roots. One of the ways that we can find these roots is the Newton-Raphson method. So the Newton-Raphson method entails that, well, we can start with initial guess x1, and the corresponding value of this initial guess on the y-axis will be equals to y of x1. So at this point, if we evaluate f, the function f, at x is equals to 1, will be equals to this distance right here, y, or y of x, equals to 1. So if we define a slope at this point, if we take a slope here, the intersection of that slope was the x-axis. We call this point x2. So now our slope is equals to f prime of x1. So we know by definition that slope is equals to rise over run. So we can also define this distance right here as delta x. So by definition, we know that slope is equals to f prime of x evaluated at x equals to 1. So this is f equals 1. We know that the rise is f of x1 and the run is delta x right here. So what is delta x? Well, we can solve for delta x from the graph. Well, delta x will be equals to that distance, which is x1, minus that distance, which is x2. We can substitute for delta x, so we can have f prime of x1 is equals to f of x1 over x1 minus x2. Now we can rewrite this equation as x2 will be equals to x1 minus f of x1 divided by f prime of x1. That means that if we want to find x2, this point right here, if you want to find this x2, we would need to start with an initial guess x1 and then evaluate our function at this initial guess f of x1 and evaluate the function at the first derivative of that equation f of prime of x1. But what if we want to find x3 to come closer and closer to that curve right here, so we can be able to find our first root? So again, we will define another point and take the slope at this point, and this will be x3. So we can see that we're getting closer and closer to our first root. So x3 will be equals to x2 minus our function evaluated at x2 divided by the first derivative evaluated at x2. So the most generic form that we can rewrite these equation, the Newton-Raphson method, will be q of n plus 1 is equals to q of n minus f of q of n divided by f prime of q of n. So this is the scalar form. That means that we have one equation and we're trying to find the roots for it. This is the scalar form. But what if we have more than one equation? What if we have something like y1 is equals to x1 squared plus 2x and y2 is equals to 2x1 squared plus 3x. This is totally random. In this case, we can still use the Newton-Raphson method, but we are going to change the form a little bit. So in this case, we will define these two equations in a form of matrix. So we will have something like q of n plus 1 is equals to qn minus the Jacobian matrix, which is partial derivative of f divided by partial derivative of q to the negative 1 times f of q of n. In this case, our f here is equals to y. In this particular scenario. So what is the Jacobian matrix? The Jacobian matrix, which is the partial derivative of f over partial derivative of q, is equals to the partial derivative of the first equation with respect to its first variable and the partial derivative of the first equation with respect to the second variable and the partial derivative of the second equation with respect to the first variable and the partial derivative of the second equation with respect to the second variable, which is q2. This is what we call the Jacobian matrix. In this form, we can solve for the any two equations and two unknowns. This is the matrix form. We will learn how to code that in MATLAB in the next tutorial.